Now, problem number 5, we need to be able to graph the quadratic equation. In this case, it's going to be much easier to graph it than on problem number 1 because they give us our h and our k. In this, when it's on vertex form, it's much easier to graph because the vertex is just given to you. -3, remember your h is the opposite, your k is the same. Let's go and plot it. -3 and +1. That's our vertex. Let's go and draw out the line of symmetry. We need to be able to find the equation for the line of symmetry. With a vertical line, so it's going to be x is equal to a number. In this case, it crosses the x-axis at -3. So this will be x is equal to -3. Now I need to find different points on the parabola in order to sketch it. You can plug in whatever values you want for x, but if we stay close to the axis of symmetry, we're going to get points somewhere close to the axis of symmetry. If you get too far from the axis of symmetry, you're going to get very large numbers. So in this case, I'm going to plug in, this is a -3, I'm going to plug in a -2, and then I'm going to plug in a -1. I'm going to let x equal to -2. So first I'm going to let the value of x to be -2. I'm going to use that equation. We have y is equal to -3. Instead of the x, I'm going to plug in a -2. We have +3 squared plus 1. And now I'm going to simplify. -2 squared is 1. We have y is equal to -3 times 1 squared plus 1. Remember to do the exponent first. That gives us 1 times -3 is -3. Plus 1 is equal to -2. If my value of x is -2, my corresponding y value is -2. So -2, that's my next point. And I'm going to reflect it to the opposite side of the line of symmetry. I need to find another set of points. I'm going to let x equal to, this was a -2, so I'm going to plug in now a -1. So give me a point somewhere around here on that -1 x. So somewhere around here. So I'm going to plug in a -1 for the x into the equation. We have y is equal to -3. Instead of the x, I'm going to replace it with a -1 plus 3 squared plus 1. I'm going to simplify what's inside the parentheses first. Y is equal to -3. -1 plus 3 is +2 squared plus 1. I'm going to go and square this first. That gives us 4 times -3 is -12 plus 1. Y is equal to -11. If my x value is -1, my corresponding y value is -11. As you guys can tell, it's a little off the chart. So we can just sketch as this. But you do need to show me the work. Remember, it's a parabola. In this case, it's facing down because of the -3. That's the a value. That tells you the shape and whether it's facing up or down. In this case, this is facing down. The vertex is the maximum. Let's continue to problem number 6. Problem number 6. Solve by completing the square. Remember, when you're completing the square, you want to be able to leave your x's on the left, your numbers on the right. Therefore, I'm going to move my 29 to the right because it's a -29. That gives me x squared plus 6x, I'm going to leave some space, is equal to -29. Now I need to complete the square. To complete the square, you're going to use the following formula. b over 2 squared. But a lot of the times I just do it in quick steps. I'm going to take the value of b, I'm going to take half of it, and then I'm going to square it. I'm going to take the value of b, I'm going to divide by 2, which gives me 3, and then I'm going to square it, so it'll be positive 9. And what I do on one side, I need to do to the other side. Now it's important that if you can do this in red, that really helps. From here, now that I complete the square, I'm going to factor the left hand side, and I'm going to simplify the right hand side. Factors of x squared will give me x and x. Factors of 9 gives me 3 and 3, and they both have to be positive. You can double check to make sure that you factor correctly. X and x is x squared. X times 3 is 3x. 3 times x is 3x. So 3x and 3x is 6x. Then 3 times 3 gives us 9. Because I have two of them, I'm going to combine them into one. And that'll be negative 20. From here, I can get rid of the square by taking the square root. I'm going to take the square root on the left and the square root on the right. The square and the square root cancel, so I have x plus 3 is equal to. Now the square of 20, you have two choices. You can do your factor tree. 5 times 4, 5 is a prime number. 2 times 2, that's a prime number. I'll place them all inside. 2, 2, and 5. The 2 comes out. And inside we have a 5. Or the way I prefer to do it, I can find what perfect squares divides 20. So square root of 4 is a perfect square. 4 is a perfect square, and then times 5. The square of 4 is 2, and then we have square root of 5. But since we have a negative inside the square root, let's not forget your I. And because we took the square root on both sides, we have the plus or minus. From here, I'm just going to move my 3 to the right, becomes a negative. We have x is equal to negative 3 plus or minus 2i, the square root of 5. Problem number 7. On problem number 7, it's asking you guys to solve by using the quadratic formula. So let's go and write down the quadratic formula on the left. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. And I prefer if you guys can do b squared minus 4ac separately. It kind of makes the work much easier. So let's go and start the process. We have x equals opposite b plus or minus square root of b squared. I'm going to do b squared minus 4ac here. All over 2a. So we have x equals opposite b. This is a 4, so this will be negative 4. Plus or minus square root of b squared minus 4ac. So let's go and work this out. That's 4. A will be 5 and c will be negative 1. All over 2a. Now let's go and simplify this out. Exponent, that'll be 16 minus 20 multiplied by negative 1. Remember, they're multiplying. That gives me 16. That gives me positive 20. So that's 36. The discriminant is 36. The discriminant goes inside the radical. From here, I'm going to simplify. I know that the square root of 36 is 6. So we have x is equal to negative 4 plus or minus square root of 36 is 6 all over 10. Since this is a whole number and not a radical and no imaginary numbers, we can actually divide this as two different equations. The first one will have a positive 6 divided by 10. The second one will have a negative 6 divided by 10. We have 2 over 10, which is negative, or just 1 over 5. Let's go and reduce it. This one will give us negative 10 over 10, which is negative 1. So those are our two solutions, 1/5 and negative 1. Remember, if you end up with an I, then you can just leave it as this. You just need to be able to separate and reduce it if possible. If you end up with a square root, you can try to reduce it, but you cannot separate into two different and simplify a whole number or a fraction. You can just leave it as this. In this case, it was easier because once you take the square root of 36, it's 6, and we can divide it. One with a positive 6, one with a negative 6, and simplify it out. Let's continue to problem number 8. On problem number 8, we have a fraction and we have a complex number on the denominator. Remember that we cannot have imaginary numbers on the denominator, so we're going to multiply by something that's called the conjugate. The conjugate is a binomial that we're going to use to cancel the i's. The only thing that we need to change is this to a positive. The force is the same. This is a negative. We're going to change it to positive 5i. The imaginary part is the only one that becomes the opposite. You have 4 plus 5i. From here, we are going to use our history property to multiply it out. So we're going to multiply that 2 times each one of them. 2 times 4 is 8. 2 times 5i is positive 10i. Negative 3 times 4 is negative 12i. Negative 3i times 5 is negative 15i squared. Over. We're going to go and multiply the denominator. We're going to distribute the 4 to both of them. 4 times 4 is 16. 4 times 5i is positive 20i. Negative 5i times 4 is negative 20i. Negative 5i times 5 is negative 25i squared. This will cancel out. Your denominators, the middle term should cancel out. I'm going to take it in two different steps. I know we've done it in one step before, but let's do it in two different steps. I'm going to combine my like terms. I have 8. That gives me minus 2i, then minus 15i squared over 16 minus 25i squared. Now, you have to memorize or remember that I squared is equal to negative 1. Therefore, this becomes negative 1 times 15 becomes a positive 15. And I'm going to combine like terms with the 8. That is 23 minus 2i over. I'm going to do the same thing. This becomes negative 1. I squared is negative 1 times negative 25 becomes positive 25. And I'll combine 16 plus 25 becomes 41. And because it cannot be reduced, now number divides 23 and 41. 23 is a prime number. 41 happens to be a prime number as well. We cannot reduce it. And that'll be our answer. Let's continue to the back side.